In this video, I'm going to explain lines of symmetry, reflection, all using GeoGebra. Now, with this, I'm going to use a real life example to explain these things. I'm going to use this picture from nature, a starfish. Blow it up so you guys can see it better. Now, just from things that you guys know from elementary school, that this shape looks symmetrical. If you folded it in half, or you folded this shape in the middle, it would be the same on both sides. I'm going to explain this using the tools we have here. So real quick, I'm going to do this line segment. If I had a line segment from here to here, we'd probably all agree that this right here is the line of symmetry. This is where the shape breaks down in the middle. And I'm going to put a point on my starfish right, let's just do it right here. I'm going to make it green just so we can see it a little bit better. Before I forget, I'm going to put, oh, that's not what I meant to do. Before I forget, I'm going to put this shape as a background image just so we can see all the lines and marks that I'm making. Now, if we had to make a prediction, this point E would reflect off of this line, and it would end up probably about right here. And this makes sense from what we know, using Pythagorean theorem, distance formulas, those kinds of things. So the distance from this point hitting this line being a perpendicular line, and reflecting off this side would be about right here. I'm going to use my tools that I have now in GeoGebra and reflect my point E across my line F. And it is right about where we thought it would be. At this point, I'm going to use this tool, and I'm going to tell it to trace my lines. And we are going to trace this point around the star, and we will be able to see point E prime move around with us as well. So as we move this around, why is it not working? Let's try this again. As we move point E around, point E prime is also going to move around, and where these lines reflect, where the starfish reflects. And it makes sense from what we know from like elementary school and all those kinds of things. But now we see why it really works. It's really cool to me. I picked this because all these lines also seem to be a reflection of each other. So I'm going to just go ahead and come up here, and I'll trace these two just to show you. I think nature's really cool, and how many different things are actually symmetrical. From body parts to things we see in the ocean to just different animals. So as you see, this point right up here reflects this point. Again, it has a lot to do with the distance formula, how far it is away from the line, and then how far away it goes off the line. Using Pythagorean theorem to find the distance in the distance formula. Also,